there's no overlap. This here, our book talks about myasthenia gravis. This is an autoimmune disorder. Here for this one, we have to know that antibodies in people who have this condition, their antibodies attack the acetylcholine receptors on the skeletal muscle fibers. So fewer acetylcholine receptors means that acetylcholine is not going to be able to do its job because there's nothing to attach to. So then fewer of these receptors, less electrical signal, and then less contraction. So this unfortunate disorder progresses. First, it starts with muscle weakness, muscle fatigue, but then later on, if the diaphragm is not able to move, because that is your breathing muscle, if you can't use your diaphragm, then you cannot breathe. Now, here are some treatments: drugs that inhibit acetylcholinesterase. This is an enzyme that breaks down acetylcholine. So if you stop this enzyme from working, then you will have more acetylcholine around, which will then increase the contraction instead of reduce it. And so I'll write down here. This is also going to talk about on the next slide. Yeah, immunosuppressant drugs will also help with combating those antibodies, administering antibodies that inactivate these harmful antibodies. Plasma exchange to supplement the good antibodies will help. Okay, well, we talked about contraction, but now the muscle needs to relax. So when the neural stimulation of the muscle fiber stops, then the muscle will end up relaxing. So here, I want you guys to know, in order for the muscle to relax, what needs to happen? Acetylcholinesterase. This is the enzyme that comes in. It's actually in the synapse between the nerve cell and the muscle. This breaks down acetylcholine. And so if you get rid of the acetylcholine, then you will lead to muscle relaxation. And so muscle impulse is going to stop when acetylcholine is decomposed. Okay, then the next thing that has to happen for the muscle to relax is getting the calcium, putting it back where it came from. So there are these special pumps. This is actually active transport. These active transport proteins are moving the calcium back into the sarcoplasmic reticulum. But then you're just going to keep it there until the next time the muscle needs to contract. Well, then when you remove the calcium, troponin, tropomyosin moves back and covers those binding sites on actin. Okay, but so here, the ones that I put the arrows on, know that these are the two things that need to happen for the muscle to relax. Okay, so next we're going to talk about the energy sources for contraction. And so we saw that ATP is needed for contraction, but also for the myosin to let go of actin. Now, 4 ways that our muscles use to create ATP or to have this contraction. Inside the muscle cells, there is some ATP, but this is a small amount. So when you start exercising, this ATP is going to run out very, very fast. Okay, but so at the beginning, you are going to use this ATP. Okay, so now we have to get more ATP. And if you remember, when you break down ATP, you get ADP. ADP only has the 2 phosphates. Now, we have this special protein, creatine phosphates. Creatine phosphates, this holds phosphates, and it donates a phosphate to ADP. And so when you add a phosphate, since ADP only has 2 phosphates, then you can make ATP. And so again, ATP was the higher energy version. ADP is the used up version. But you want to get the ATP to do the cell's processes. The next one, after you run out of creatine phosphates, well then the muscle cell has to perform cellular respiration. And so the cellular respiration, remember, it takes place in the mitochondria. It needs oxygen, but it does make a lot of ATP. But now you keep on exercising, and now you're going to run low on oxygen. When the muscle cells run low on oxygen, then they only perform glycolysis. So that was the first step of cellular respiration. When they perform glycolysis, pyruvate is formed, but pyruvate has nowhere to go, then pyruvate is going to get converted to lactic acid. So basically what we learned in, I believe this was chapter 3, cellular respiration. So these were the steps. There's glycolysis, citric acid cycle, the electron transport system. It makes a lot of ATP, but it does need oxygen. Now, there's actually this another protein inside our muscles, myoglobin. Myoglobin stores extra oxygen inside the muscles. So when you're exercising, this myoglobin brings oxygen, but of course, eventually it's going to run low. And this myoglobin has a red color when it's attached to oxygen. Okay, but so when the oxygen runs low, then only glycolysis is performed. So here only glycolysis is occurring, and then know that it's the lactic acid that forms as a result of only doing glycolysis, the anaerobic. Okay, next few things here. Oxygen debt. So what this is saying is during rest or moderate exercise, respiratory cardiovascular systems, they supply enough oxygen to support aerobic respiration. Okay, so if you're not doing a very high energy, high level of an activity, you have enough oxygen. But if you have used up a lot of oxygen when you're exercising, then your body needs to build it back up. So here, anaerobic lactic acid threshold says here shift in metabolism from aerobic to anaerobic during strenuous muscle activity. And so then the above systems cannot provide the enough oxygen, and so it's saying lactic acid is produced. Okay, but so once you stop exercising, you have to get back that oxygen. And also this oxygen that you need to replenish is needed by your liver cells. Liver cells can actually take that lactic acid and they can convert that lactic acid to glucose. So at least that lactic acid doesn't go to waste, at least because it does still have that energy. But yeah, so liver cells are using oxygen to convert that lactic acid, and oxygen is needed to restore the ATP that's inside the muscle before you start exercising because you need to bring that back up, and also creatine phosphate levels need to be replenished as well. Muscle fatigue. This is a weird condition. So muscle fatigue means inability to contract muscles. So it doesn't just mean, oh, I feel tired, I can't move, I don't want to exercise, but muscle fatigue means literally muscles cannot contract. This happens at the end of marathons. So people you may see on TV at the end of marathons, they just collapse and cannot move anymore, they can't get back up. But it is only temporary, so that's good. So common causes of muscle fatigue: decreased blood flow, so perhaps not enough oxygen coming in and too much lactic acid being formed, ion imbalances, and so then this is actually causing, well, the theory goes that the lactic acid is damaging the sarcoplasmic reticulum and the calcium is not able to get released from the sarcoplasmic reticulum. Okay, then muscle cramps. It's also very interesting. It's also caused by imbalances in the electrolyte levels in your body. So potassium levels, hydrogen levels, if they're not in the right balance, a person may experience muscle cramps. So muscle cramps, I'm just going to write down involuntary muscle contractions. So you're not in control of it, your muscle is contracting, but it's because of those potassium levels, hydrogen levels not being